periodic table is less helpful when naming transition metals because there's less of a good pattern here. Really, there's very little pattern at all. Also, many, but not all of our transition metal ions can form more than one type of ion. If you're given a formula for just the ion, like here with silver plus, then you know what the charge is. Be careful though, because silver is one of our transition metals that will form one single ion, and that has a 1+ charge. Because it can't do more than one thing, including the Roman numeral for the name is incorrect. This would just be the silver ion or the silver cation. Either one would be correct. Sometimes you might have to do some work to figure out the charge on your transition metal ion. Our second example illustrates that. Cobalt can form more than one ion, and I'm not given the charge here. I am, however, given the chemical formula for an ionic compound. The anion involved is one that adopts a single common charge, so I can use that and the fact that ionic compounds are neutral overall to determine the charge on the cobalt. Follow along with me while I math this out. Our compound has one cobalt cation that I don't know the charge of yet. It also has two iodide anions that I know carry a characteristic charge of 1-. And, by definition, our cations and anions have to come together in such a way that our ionic compounds are neutral overall. Facts are good. Now, let's convert our words into an algebraic equation. Again, a single cobalt, which is an unknown, and two iodines have to form a compound that is neutrally charged. Plug the charge in for the iodide into your equation and then solve for your unknown. Here, it simply says cobalt, but know that the charge on the cobalt cation is actually what you're solving for, which means we can now name our cation cobalt-2 ion. Note that there is not a space between the cobalt and the parentheses. This is a great time to point out that chemistry is a neat and terrible combination of theory and math. There's something for everyone. But we will often have to use our theory, such as definitions, facts, etc., to inform our calculations, which we just did, so we're already doing great. You'll determine the charge on the next two cations in a very similar manner. I'll forego doing the math as you can follow the model we used here for cobalt-2 iodide. Iron will have a charge of 2+ in this oxide compound, so this would be named iron 2. This is a really important one to include the charge for, as there are multiple oxides of iron. The platinum will have a charge of 4+ in PtO4. This means that the ion's name is the platinum 4 ion or the platinum 4 cation. We are given the charge for chromium, so we simply have to remember that it can adopt multiple oxidation states and will need a Roman numeral to come up with the chromium 2 ion or chromium 2 cation. Another trick for you here at the end, because chemistry is just the best. Zinc is another of our transition metals that only adopts a single transition state, so this will simply be named the zinc ion.